Guys, the FGC 2025 challenge is here. Oh, wait. There's two chairs at a distance of 10 feet. And you have to pick up sea horses from one end and place it in a basket at the other end. I think we need a very fast drivetrain to cover the 10 feet distance.
We also need a long mechanism that can catch sea horses and deposit them into the basket.
I see. Newton's law of motion is applied. Where I think we can use pulley system.
Let's do it.
So our journey started off by doing a lot of testing and R&Ds. So we started our mechanism with Omni wheels. So talking about this, it provided us very limited directions and was too slippery. So we thought to change to miter gears and mechanism wheel, but that had a lot of friction. So then we moved on to the pulley system and the mechanism wheels.
Then we started figuring out how we would extend our robotic arm so that we could reach the corals easily. We started by making these linkages that would be run by the bars, but we found that they had little reach and was very slow. We then made a telescopic arm that would extend using a string, but we found that this mechanism was also slow and was even more rough. We finalized on the Go Builder Viper sliders.
Coming to the grabbers, we first started by making this 3D printed grabber with two interlocking gears at the base. However, we felt that this mechanism was too slippery and could not give us a good grip over the seahorses.
So we switched to version 2, which was thin and light, but it failed to provide the grip needed to grasp the seahorses. So in the end, we switched to version 3, which was a slightly thicker and had a kink at the edge.
Coming to the design of our final robot, our chassis includes 4 mechanism wheels, which enables the robot to move in 10 directions. We have got 4 Go Builder motors with 435 RPM specification. The pulleys and belts help to reduce friction and to increase speed of the robot. We have got a 1:1 pulley ratio and a 13.7:1 gear ratio in our robot. Additionally, we have also used metal channels to provide robust support to the robot.
And then we came up with the final design of the grabber, which consisted of one part which had 15 teeth, and then this had 3 servo motors, 2 being 300:1 and 1 being 135:1, and this allowed us to have various motions.
We realized that we had to pick and place the seahorses at different angles, so we needed a strong and robust arm. To do this, we made a 3:1 sprocket ratio and a 117 RPM motor, which had a 50.9:1 gear ratio. So it provided enough torque that it could stop at any point in the radius. This provided for easy picking and placing at whatever angle we needed.
Realizing the fast pace of the game, we decided to use customized cascading Viper sliders, where each stage opens up faster than the previous one. There are main 3 strings, one for cascading, one for retraction and one for extension. We use 1:3 gear ratio for opening of the mechanism, which makes it faster.
Talking about the final design of our robot, we have used 6 hex shaft motors, 4 for the drivetrain, 1 for the extending mechanism and 1 for the arm mechanism. Then we have used mechanism wheels in the drivetrain. Then we have used 1 U channel and 1 C channel, both of them connecting the parts of the robot, and C channel also provides support to the arm mechanism. Then we have used a belt driven system, hence we have used pulleys and belts.
We are Team Akam. Akam means unity, and that's what we stand for. Through innovation, teamwork, and outreach, we lived the 4 school values to the fullest. We discovered that real impact comes from lifting others as we rise.